Okay, so in this video I will show how to calculate a stress flow curve. The file I'm loading is contained in this folder. It's an aluminum alloys, and the test has been done at 100 degrees, so it's a compression, hot compression. If we zoom in this file during the heating part here, you can see the thermal expansion here. So I was just moving the cursor on the left side here to mask all the last values, and so this is the heating part, and holding prior to deformation, and then we have here the deformation itself where the diameter of the sample increases rapidly. So the importance to understand is that to calculate a stress flow curve, we would want to take into account the thermal expansion of the sample. That is, the diameter of the sample has changed as we do the test at high temperature. So if we want to know that value here, that's just this value here. The diameter of the sample is the initial value plus 74 micrometer here. So that value we will keep in mind. And so to calculate the stress flow curve, we would set ourselves into function mode, select the flow stress cylinder, and then here we would place here the x value of the stress flow curve is calculated from the dilatometry. The y value of the stress flow curve, the stress, is calculated from the force. And here we have the option to set the stroke so as to calculate the longitudinal stress, the longitudinal strain during the curve. So this parameter x would give us the diametric strain, and here would give us the longitudinal strain. So here then we have 4 parameters to enter. That is the initial length, 15 millimeter, the initial diameter, 10 millimeter, and then the contribution from the length due to the elevation of temperature. We will neglect that for the moment, so we're just gonna write down like 100 micrometer. And then the one that is important is this 75 or 74.6 micrometer contribution from the thermal expansion in the diameter. Just put this here, and then I calculate this. It gives us a message that says that there is a file that has been created, and that this file has an extension _fs for flow stress. So the diametric true stress and true strain will be shown to illustrate then that the calculation is acceptable. So that's the calculation that we have now. And so if I click on run here, it gives us the possibility to zoom in the stress flow curve. So put the values here from, let's say, 0 to 0.25, it was good. And in stress 0 to 360, that's also good. So that's the stress flow curve that we have calculated here. Of course, we could load this new file that is now present in the same folder with an extension _fs. What you can see here is that you have now a number of additional columns here, which are diametric true strain, diametric true stress, and also longitudinal true stress and true strain, as well as engineering stress and strain for longitudinal and diametric. So just as an example here, I'm just gonna replot the diametric true stress, true strain, and the diametric true stress in Y. And then what we can do, as always, export the graph one so as to have a figure. So that's the first video on calculating the true stress, true strain curve after a GLEEBLE testing. In the next video, I will show how to do the same thing on up to 10 files together simultaneously.